we should have probably filmed more of this, but we weren't sure if we were going to do it to this extent, so we didn't. But we're ready for testing today. Obviously, it's a solar panel array, single axis rotation, because the sun here just happens to go straight up and over. This is, in case anybody else wants to build these. I know these are super expensive to buy, and so I tried to do it less expensive. It'll hold 36 panels if they are the 650s. These are the 650 watt Canadian solar bifacials. These panels are actually huge. I believe they're 96 inches tall by 54 inches wide, if I remember right. So more than 4 feet and almost 8 feet. If you went with smaller 300 watt panels, 400 watt panels like most people use, then it would hold a lot more. For our particular setup, I use 11 of these in one string per inverter. And that gives me about 7,000 and change watts per inverter. They're rated for 6,200. But if you go over a little bit, it doesn't hurt anything. They only use what they can. And it helps when it's not bright and sunny. When it's cloudy, partly cloudy, it keeps the voltage up. You want to get your string voltage as high as you possibly can without going over what the inverters are rated at. My inverters are rated at 500 volt DC coming in. So these panels right here, you'll have to look at the voltage on your panel in particular. But these right here with 11 of them in series, that's just positive, negative, positive, negative, positive, negative, all the way on down. With 11 of them in series, I'm at 496 volts, which is as close to 500 as I could get without going over. Because inverters, when they go to charge and make power, they put it under load, just like anything else. Like if you have a battery and you read the voltage on it and then you hook up a light bulb to it, you'll notice the voltage will drop a little. That's really your maximum power point, okay? So the minimum voltage on those particular inverters for them to work is, I think, 175 volts. So if the voltage on your string drops below 175, then you get nothing. Okay, so that's why you want your voltage as high as you can, because it can load it and 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 keep bringing the voltage down, but your amps are going up, so you're making a whole lot more power that way. So anyway, kind of a long story, but I use 11 of them in a string, so I wanted it to hold 33. And we got a couple extra spots. This is 4-inch schedule 40 pipe. Okay, these are 2.5-inch by 1/8-inch flat bar. I just took torch, notched them so that they would set on the pipe so I could weld them on there. And then I used a spacer in between to space them so the panels fit exactly in between them. And drilled holes in the end, and as you can see, there's bolts. This is the end panel, but they bolt through the sides of the panels and the bar, and that sandwiches everything together. And I just put the bars here because the frames on these, I don't believe, are strong enough to just mount them in a small footprint. I don't think it would hold. For some reason, as the panels got bigger, the frames got smaller, which doesn't make sense to me. The regular 300 watt panels, which are only about this big, have 2-inch frame. These, which are considerably larger, only have 1.5 inch frame. And they're quite flexible. You can set them on there and you can twist them back and forth 6-8 inches per side. Whereas those are way more rigid, the smaller ones. But anyway, I put these in there just because I figured it would need something to stiffen the panels up. I had a machine shop cut the brackets. I designed the brackets. They just sit on top of the post and are welded on. And they got holes, 3 sets of holes. I just ended up using 2. And I put a bearing on either side of a bolt and bolt it through there so the pipe just sits on the bearings. When we were done, before we actually put the panels and stuff on there, you could spin the whole thing with one hand. It was really quite nice, worked out well. Then in order to move it, it's always a challenge. The best we could come up with was linear actuators, was the simplest. I cut some brackets out of 2" by 3/16 angle iron, notched them to fit the pipe, welded them on, measured out. I just wanted 12 inches worth of leverage, so from this edge of the pipe to that bolt's 12 inches, which should reduce the load on the actuator from the weight of the panels, because they're only 1.5 inches off of center. So that gives it 4 to 5 times mechanical advantage. Reduces your throw though. Won't travel as far, but stronger. And then put the other mounting bolt down there, just welded it straight to it. A couple of washers, nut. And for testing, hope everything goes well. I just ran some wire all the way down. You can see it's just temporarily zip tied up there. Put some wire nuts at each actuator. Each actuator is rated for 5 amps. So I've got 4 of them, and then a cable that goes across, and then another 4 and a cable that goes across. So that gives you 20 amps worth of cable going to each set of 4. And the other way that originally I was going to rotate it, but didn't like the way it was working out, was I was going to put a chain and like a winch drive, and then you'd be able to rotate it completely full limit in any direction. I didn't think that was enough leverage on there, and I was a little worried that over 150 feet the pipe might candy cane on it, which initially when we put it together we thought that was a crazy idea, but then when you started to get some weight on it and some panels on it, we were like, you know, that's probably a real thing. And I took and screwed 2x4s and 2x6s to the backs of them down through there after I put the panels on to hold it steady while I put on all the electronics. And a couple of things I learned. This was one of the brackets too, and originally I had them cut with a loop over the top like that so that the pipe couldn't escape. But what I found after I started putting the panels on was they were too close to that loop. Like this is an example. One of the little connection boxes right there is sitting right on top of it, and it wouldn't work. So on the next one I'll either have to cut these smaller on the top or put a larger piece of flat bar to move them out a little further. So I ended up just going back with an angle grinder and cutting them off. What I'm going to do is take winch cable and run it around it and under through there, and then put a clamp on it and pull it snug, and that way it'll provide the same thing, won't allow it to lift out of the track. It doesn't seem like it would because the whole structure weighs about 5,000 pounds, and I've tried putting my shoulder under it and picking it up, and you can't. But it's a lot of surface area. You get some wind, I think it's possible that it could lift it up out of there. I've ordered just a cheap little east-west tracker They're like $45. It's cheaper to order it than it is to try to build one. It should be here next week. In the meantime, it'll give me a chance to get all the cabling good and the panels all made up down through here, and then I got to pull wire back to the shop. I've got the conduit in. So I got plenty to do for the next couple of days while I'm waiting on that. So, only thing left, I guess, is to try it.